Consider a motor that exerts a constant torque of 25 Newton meter to a horizontal platform whose moment of inertia is 50 kilogram square meter. Assume that the platform is initially at rest and the torque is applied for 12 rotations. Neglect friction. How much work W does the motor do on the platform during this process? This numerical is based on rotational work. So work done is equal to torque times angular displacement. Just like work in linear motion is equal is force dot displacement. Okay, we write like this. The same way we have to write the work in the rotational motion as torque times angular displacement. Here, force times displacement. Here, torque times angular displacement. So torque is given as 25 Newton meter, and then angular displacement is given as 12 rotations. We have to convert the rotations into radians. So one rotation is equal to 2 pi radians. Therefore, 12 rotations is equal to 12 times 2 pi, which is 75.39 radians. Okay. So multiplying that one, we will get the work done as 18.1885 joules. Okay, 1884.75 joules. And so rounding it, we will get 1885 joules. Next, what is the rotational kinetic energy of the platform at the end of the process described above? This is based on work energy theorem. So work is equal to change in energy, delta K. So initially the platform is at rest. Therefore, this is equal to half I omega F square minus half I omega I square. Okay, so this is equal to 0. Therefore, this is equal to half I omega square, which is nothing but the work done. Work done is equal to this one. So the same. 1885 joules is the rotational kinetic energy. Next. What is the angular velocity of the platform at the end of this process? So here half I omega F square is equal to 1885. And then omega F square is equal to 2 times 1885 divided by moment of inertia. And moment of inertia is given as 50 kilogram square meter. So substituting this one, we will get omega F is equal to 8.68 radians per second. This is the answer for this one. Next, how long does it take for the motor to do the work done on the platform calculated in part A? Now we have to calculate the time, how much time the motor takes to do this much of work. Okay, so for that what we do is we take the this one, omega is equal to delta theta by delta t. Am I right? So here delta theta is known to us because given in the problem itself, that is 17.39 radians. And then omega is the angular velocity. Angular velocity is equal to, we have to take the average because initially it is at rest and then the final angular velocity is 8.68 radians per second. So we have to take the average. So average angular velocity is equal to 4.34 radians per second. Okay, so that is equal to delta theta by delta t. Therefore, delta t is equal to 17.37 or 17.4 seconds. Okay. Next, what is the average power delivered by the motor in the situation above? Now, power is equal to work by time. Rate of doing work is called the power. Therefore, it is equal to 1885 divided by 17.37 is equal to 108.5 watts. Okay. Next. Note that the instantaneous power P delivered by the motor is directly proportional to angular velocity. So, as P increases, as the platform spins faster and faster, how does the instantaneous power being delivered by the motor at the time Tf compare to the average power calculated in part E? Now, what he is saying is, suppose if the platform spins faster and faster, what will be the instantaneous power? Obviously, the instantaneous power will be more, okay, compared to the average power. We are taking the average power, so average power will be always less than the instantaneous power because initially it is at rest and then finally it has some velocity, angular velocity. We are taking the average and then calculating. Therefore, the average power will be always less than the instantaneous because at a particular instant the value will be high, no? So he is saying faster and faster. The platform is spinning faster and faster. So of the given choices, only one is the more. The P is equal to P average, wrong. And then P is equal to P average by 2 is also wrong. None of the above is also wrong. And then this choice is the correct answer. Okay. Hope this helps. Thank you. Bye bye.